Hello students, welcome to my channel Halla Bol Physics. Okay, today's topic is bimetallic strip. Bimetallic strip. Okay, question is arising here. What is bimetallic strip? What is bimetallic strip? You know, by the name it is clear here. What mentioned here? It is bimetal. What mentioned here? It is bimetal. Bimetal means two metals. Bimetal means two metals. So bimetallic strip is made of two different materials. Is made of two different materials. Now, how to define bimetallic strip? Yes, we have taken a diagram on the board here. This is the diagram of a bimetallic strip. Is the diagram of a bimetallic strip. Upper strip is made of coefficient of linear expansion alpha 1 and the lower strip is made of coefficient of linear expansion alpha 2. Now, what is our question here? How to define bimetallic strip? Simple. When two different material strips are joined one over another, to form a single strip. That strip is known as bimetallic strip. Now question is arising here, what is the use of the bimetallic strip? What is the use of the bimetallic strip? Simple, it is used for automatic breaking of the circuit. It is used for automatic breaking of the circuit to prevent excess heating. In iron and in geyser. To prevent excess heating in iron and in geyser, we use bimetallic strip. Now, to prevent excess cooling, in refrigerator and in AC we use bimetallic strip. To prevent excess heating and excess cooling, we use bimetallic strip. Now we have taken two conditions. One condition when a bimetallic strip is heated and the another condition when a bimetallic strip is cooled. As you know, a bimetallic strip may heated or may cooled. So when a bimetallic strip is heated, we are taking on this side. When a bimetallic strip is cooled, we are taking on the another side. Now, we have taken two diagrams on the board here. Both are the diagram of a bimetallic strip. Upper strip is made of coefficient of linear expansion alpha 1 and lower strip is made of coefficient of linear expansion alpha 2. Initially, this bimetallic strip is straight. Of length is L naught. Now we have taken a condition on the board here. If alpha 1 is greater than alpha 2, here also if alpha 1 is greater than alpha 2. Now one question possible to arise in our mind, why we are taking alpha 1 is greater than alpha 2, why we are not taking alpha 2 is greater than alpha 1? Yes, it should be clear here, either we are taking alpha 1 is greater than alpha 2 or alpha 2 is greater than alpha 1. The statement which we want to discuss in a class related to the bimetallic strip, these statement will not be changed. Either we are taking alpha 1 is greater than alpha 2 or alpha 2 is greater than alpha 1. So anyway we can start here, either alpha 1 is greater than alpha 2 or alpha 2 is greater than alpha 1. But it must be clear here, alpha 1 will not be equal to alpha 2. Reason, we know it here, a bimetallic strip is made of two materials. So two material means alpha 1 will not be equal to alpha 2. So we can discuss either by alpha 1 is greater than alpha 2 or alpha 2 is greater than alpha 1, but not alpha 1 is equal to alpha 2. Suppose we are taking here if alpha 1 is greater than alpha 2. Now condition is mentioned here. Here bimetallic strip is heated. Bimetallic strip is heated. Heated means temperature increases. Heated means temperature increases. Temperature increases means T final is greater than T initial. T final is greater than T initial. So what we can take here, T final is greater than T initial. What is change in temperature is always T final minus T initial. Change in temperature always T final minus T initial. Now from here it is clear T final is more than T initial. Due to this delta T will be positive. Delta T will be positive. Now initially bimetallic strip is straight, its length is L naught. Now when bimetallic strip is heated, bimetallic strip is heated, what is the final length of the upper strip is supposed to be L1. Final length of the lower strip is supposed to be L2. L2. So what is the final length of the upper strip is L1 is equal to initial length is L naught into 1 plus alpha 1 into delta T. 1 plus alpha 1 into delta T. What is final length of the lower strip? Final length of the lower strip is L2 is equal to L naught into 1 plus alpha 2 into delta T. Yes, it must be clear here. Delta T is positive. Positive will be positive. Positive will be positive. Now initially bimetallic strip is straight, of length is L naught. So this length is same L naught. Upper strip and the lower strip both are heated to the same temperature. Both are heated to the same temperature. So delta T is also same. Delta T is also same. Now here alpha 1 is greater than alpha 2. Here alpha 1 is greater than alpha 2. What does it mean by this here? Tell me now. Higher the value of alpha 1, higher the value of alpha 1, higher will be the length L1. Higher will be the length L1. Lower the value of alpha 2, lower will be the length L2. Lower will be the length L2. So here alpha 1 is greater than alpha 2 is proving that L1 is greater than L2. L1 is greater than L2. Now this is the very important relation we have taken on the board here. L1 is greater than L2. What does it mean by this here? L1 is greater than L2. L1 is greater than L2 is proving that a bimetallic strip is not straight. A bimetallic strip is not straight. And if bimetallic strip is not straight, what does it mean by this here? Simple, we can say if L1 is greater than L2, a bimetallic strip will bend into a arc. Will bend into a arc. So what we can take here? L1 is greater than L2. Yes, a bimetallic strip will bend into a arc. Bend into a arc. Now from this diagram it is clear here. This length is L1. Its coefficient of linear expansion alpha 1. This is length L2. Their coefficient of linear expansion alpha 2. Yes, more alpha, more length. Less alpha, less length. This is known as convex side. Which side? Convex side, or we can say outer side. What we can say? Outer side. Here it is concave side. This one is concave side or inner side or inner side. So if alpha 1 is greater than alpha 2 means L1 is greater than L2. L1 is greater than L2. More alpha, more length will be on convex side or outer side. Less alpha, less length will be on concave side or inner side. Will be on concave side or inner side. So what we are learning from this part now here, when a bimetallic strip is heated, larger alpha will be on convex side. Larger alpha will be on convex side or outer side. Smaller alpha will be on concave side or inner side. Yes, smaller alpha will be on concave side or inner side, and bending of a bimetallic strip will take place towards a smaller coefficient of linear expansion rod. Bending will take place towards a smaller alpha. Bending will take place towards a smaller alpha. Now, when a bimetallic strip is cooled, we are taking a condition now here. When a bimetallic strip is cooled, cooled means T final is less than T initial. T final is less than T initial. So this is T final is less than T initial. What is change in temperature is always T final minus T initial. Now T final is less than T initial. So if T final is less than T initial, delta T will be negative. Delta T will be negative. So it must be clear here, when a bimetallic strip is heated, yes, heated means delta T positive. Heated means delta T positive. And when a bimetallic strip is cooled, cooled means delta T negative. Delta T negative. So delta T coming negative. Now, when a bimetallic strip is cooled, what is the final length of the upper strip and what is the final length of the lower strip? Yes, final length of the upper strip is L1 is equal to L0 into 1 minus alpha 1 into delta T. 1 minus alpha 1 into delta T. Don't be confused by this. Here it is plus, but here it is minus. Here delta T was positive, but here delta T negative. So negative positive will be negative. Negative positive will be negative. What is final length of the lower strip is L2 is equal to L0 1 minus alpha 2 into delta T. 1 minus alpha 2 into delta T. So this is the final length of the upper strip. Here is the final length of the lower strip. Initially bimetallic strip is straight, of length is L0, of length is L0, and both strips are cooling to the same temperature. So delta T is same. Delta T is same. Here alpha 1 is greater than alpha 2. Yes, if alpha 1 is greater than alpha 2, what is proving that we will take in a class now here? Yes, more alpha 1, less will be the length. If alpha 1 is more, L1 will be less. If alpha 1 is more, L1 will be less. If alpha 2 is less, L2 will be more. L2 will be more. Don't be confused by this here. More alpha 1, more will be the length L1. Less alpha 2, less will be the length L2, because here it is plus but here it is minus. If it is more, it will be less. If it is less, it will be more. So here alpha 1 is greater than alpha 2. It means L2 is greater than L1. L2 is greater than L1. More alpha 1, less length. Less alpha 2, more length. So L2 is greater than L1. L2 is greater than L1. Now again, this is the important relation we are taking on the board here. L2 is greater than L1 is proving that again bimetallic strip is not straight. It is not straight. It is bending into a arc. Is bending into a arc. Yes, L2 is greater than L1. Yes, diagram will be this now here. This is the diagram of a bimetallic strip. Here it is L1 is alpha 1. Here it is L2. Here it is alpha 2. Now this is concave side. Here it is concave side or inner side or inner side. Here it is convex side. It is convex side or outer side. So this is concave side or inner side. Here is a convex side or outer side. Yes, listen now here. More alpha, less length. More alpha, less length. Less length will be on concave side or inner side. Yes, less alpha, more will be the length. More length will be on convex side or outer side or outer side. And bending will take place towards larger alpha. Bending will take place towards larger alpha. So what we are learning from this part here, when a bimetallic strip is cooled, when a bimetallic strip is cooled, larger alpha will be on concave side, larger alpha will be on concave side or inner side, smaller alpha will be on convex side or outer side, and bending of a bimetallic strip will take place towards larger alpha, towards larger alpha. Okay, now we can discuss the mean radius of a bimetallic strip. Mean radius of a bimetallic strip. Yes, we have taken two diagrams on the board here. Both are the diagram of a bimetallic strip. Both are the diagram of a bimetallic strip. Is a diagram of a bimetallic strip before rise in temperature. Before rise in temperature is the diagram of a bimetallic strip after rise in temperature. After rise in temperature. Now, in this diagram, diagram, L naught is the initial length, L naught is the initial length of a bimetallic strip. Alpha 1 and alpha 2 both are the coefficient of linear expansion, both are the coefficient of linear expansion of upper strip and of lower strip. Small d is the thickness of each strip, small d is the thickness of each strip. Now, after rise in temperature, a bimetallic strip is bending into a arc. A bimetallic strip is bending into a arc. In this arc, R1 is the radius of upper strip. R1 is the radius of upper strip. R2 is the radius of lower strip. Theta is the angle made by the arc of a bimetallic strip. Theta is the angle made by the arc of a bimetallic strip. L1 is the length of upper strip, L1 is the length of upper strip, and L2 is the length of lower strip, Now bending of a bimetallic strip is looking very large, but actually bending will not be very large, bending will not be very large. It is just for your better understanding we are taking a diagram on the board here, otherwise bending will be very small. Yes, bending will be very small. Yes, we have taken a diagram on the board here. This is the diagram of a bending of a bimetallic strip, is the diagram of a bending of a bimetallic strip. So bending of a bimetallic strip will not be large, bending of a bimetallic strip will be very small. Very small bending means it is almost straight, it is almost straight, and almost straight means expansion will be almost one dimensional, expansion will be almost one dimensional. So if expansion is one dimensional, we can take L1 and L2, we can take L1 and L2. So what is the value of L1 is equal to L naught into 1 plus alpha 1 into delta T is supposed to be taken as relation number 1. Now, what is the value of L2 is equal to L naught into 1 plus alpha 2 into delta T. This is relation number 2. L1 is the final length of the upper strip. L2 is the final length of the lower strip after rise in temperature, Now, angle is equal to arc upon radius. Angle is equal to arc upon radius. So, this angle is equal to arc upon radius. This relation will now be helpful to develop two more relations in a class here with the help of this diagram. Angle is equal to arc upon radius. Angle is theta, arc is L1, radius is R1. So, the value of theta is equal to angle is equal to theta, arc is equal to L1, radius is R1. So L1 is equal to R1 into theta. L1 is equal to R1 into theta is supposed to be taken as the relation number 3. Now again, for the lower bimetallic strip, angle is equal to arc upon radius. Angle is theta, arc is L2, radius is R2. So what is angle is theta, arc is L2, radius is R2. So what is L2 is equal to R2 into theta. So we are developing two more relations here. L1 is R1 into theta and L2 is R2 into theta. Now, if we are taking 1 minus 2 here, suppose we are taking 1 minus 2, what will come here? L1 minus L2 will become equal to L naught into alpha 1 minus alpha 2 into delta T. So, after solving 1 minus 2, you will get this relation L naught into alpha 1 minus alpha 2 into delta T. Now, what is 3 minus 4? 3 minus 4. Yes, 3 minus 4 will give L1 minus L2 is equal to R1 minus R2 into theta. L1 minus L2 is equal to R1 minus R2 into theta. The value of R1 minus R2 we can find from this diagram here. All students here, if this thickness is small d, this will be d by 2. This will be d by 2. It is also d by 2. So this total thickness is d. So what is the value of R1 minus R2 is equal to small d. So the value of R1 minus R2 is equal to small d. Now this R1 minus R2 is equal to small d, L1 minus L2 is equal to yes L0 into alpha 1 minus alpha 2 into delta t. So put the value of L1 minus L2 here, L0 into alpha 1 minus alpha 2 into delta t is equal to what is the value of R1 minus R2 is small d into theta, small d into theta. So we can solve this relation to get the value of theta. What is the value of theta is equal to L0 into alpha 1 minus alpha 2 into delta t by small d. This will give the value of theta. You know all students here, theta is the angle made by the arc of a bimetallic strip. Theta is the angle made by the arc of a bimetallic strip. Or we can write this theta is equal to L0 into alpha 1 minus alpha 2 into delta t is t final minus t initial divided by small d. So we are writing this relation in this term here of theta. Now one important question possible to arise here, a bimetallic strip is used to measure the temperature. How bimetallic strip is used to measure the temperature, or how to say here bimetallic strip can be used as a thermometer, can be used as a thermometer. Yes, we will correct our this doubt with the help of this relation. This relation will be helpful to correct our these doubt in a class here. But how it is, I want to take in a class now. In this relation, L0 will be a given part here. L0 is the initial length of a bimetallic strip. So L0 is a given part here. Alpha 1 and alpha 2 will also be a given part here. So alpha 1 and alpha 2 also given part here. T initial is the initial temperature of a bimetallic strip, and the initial temperature of a bimetallic strip will be equal to the room temperature, will be equal to the room temperature. So T initial is also given. T initial is also given. D is the thickness of the each strip, which is also given, which is also given. Now the same bimetallic strip is placed inside the furnace, is placed inside the furnace having a very high temperature, furnace having a very high temperature. Yes, after some time when a bimetallic strip is taking out from the furnace, it will bend into a arc, it will bend into a arc. We can measure the value of theta, we can measure the value of theta. So we can put the value of theta after bending of a bimetallic strip. After taking these all data here, one data still is unknown. This is T final, this is T final. This is the final temperature of furnace, is the final temperature of furnace. So what was the final temperature of the furnace? Yes, we can find out with the help of this relation, with the help of this relation. So what is the use of a bimetallic strip to measure the temperature, to measure the temperature? Or it can be used as a thermometer, it can be used as a thermometer. So what is the value of theta is coming here? Theta is equal to L0 into alpha 1 minus alpha 2 into delta t by small d. Theta is the angle made by the arc of a bimetallic strip. Theta is the angle made by the arc of a bimetallic strip. But here we have to find out the mean radius. What we have to find out the mean radius. So how to find out the mean radius? By adding 1 and 2. By adding 1 and 2. Yes, adding 1 and 2, you will get L1 plus L2 is equal to L0 into 2 plus alpha 1 plus alpha 2 into delta t. After solving 1 plus 2, you will get this relation here. L1 plus L2 is equal to L0 in bracket 2 plus alpha 1 plus alpha 2 into delta t. Now we can add 3 and 4. 3 and 4. After adding 3 and 4 will come L1 plus L2 is equal to R1 plus R2 into theta. R1 plus R2 into theta. Now dividing by 2 on both sides in this relation. Dividing by 2 on both sides. What will come here? L1 plus L2 by 2 is equal to R1 plus R2 by 2 into theta. R1 plus R2 by 2 into theta. Now this is nothing but as the mean radius of a bimetallic strip. So R1 plus R2 by 2 is the mean radius, is the the mean radius. So R1 plus R2 divided by 2 is equal to capital R. What is capital R? Is the mean radius, and the value of L1 plus L2 we can take from here. The value of L1 plus L2 we can take from here. R1 plus R2 by 2 is equal to R, and the value of theta we can take from here. So we can put all these value in this relation here. What is L1 plus L2 is L naught into 2 plus alpha 1 plus alpha 2 into delta T divided by 2 is equal to this, the value of the mean radius. Its value is equal to capital R, and the value of theta we already find out here. Yes, this is L naught into alpha 1 minus alpha 2 into delta T by small d. So we are putting all values in this relation here. Yes, L naught will be cancelled. Yes, L naught will be cancelled. The value of the mean radius will come. It is d times of 2 plus alpha 1 plus alpha 2 into delta T divided by, it is 2 times of alpha 1 minus alpha 2 into delta T. This is the mean radius of a bimetallic strip. Now it should be clear here, mean radius of a bimetallic strip does not depends upon the initial length. It is clear from here, L naught is cancelled. So either the initial length of a bimetallic strip is L naught or 2L naught or 3L naught. Mean radius does not depends upon the initial length. Mean radius of a bimetallic strip does not depends upon the initial length. Now question is again arising here, is it mean radius is directly proportional to delta T or inversely proportional to delta T? Yes, this is the doubt here. Is it R is directly proportional to delta T or inversely proportional to delta T? We can simplify this relation. R will come, it is 2D divided by 2 times of alpha 1 minus alpha 2 into delta T plus it is D times of alpha 1 plus alpha 2 into delta T divided by 2 times of alpha 1 minus alpha 2 into delta T. So we are simplifying this relation. A relation is converting into this term. What is cancel? Delta T. Now picture will be clear here. Mean radius of a bimetallic strip depends upon which factors? Simple. R is directly proportional to the thickness of the each strip. More will be the thickness of the each strip, more will be the radius. So R is directly proportional to the thickness of the each strip. And the next, R is inversely proportional to the change in temperature. More change in temperature, less will be the mean radius. Less change in temperature, more will be the mean radius. Or we can take here, more will be the change in temperature. More change in temperature, more will be the bending. And less change in temperature, less will be the bending. We have taken two diagrams on the board here. More will be the change in temperature, more will be the bending, less will be the mean radius. Less change in temperature, less will be the bending. Less will be the bending means more will be the mean radius. So R is inversely proportional to delta T. So more change in temperature, more will be the bending, less will be the mean radius. Less change in temperature, less will be the bending, less bending means more will be the mean radius. So mean radius is directly proportional to the thickness of the each strip, inversely proportional to the change in temperature. Mean radius of a bimetallic strip does not depends upon the initial length. Okay, now we can discuss few questions related to the bimetallic strip. Yes, first question we are taking on the board now. When a bimetallic strip is heated, then a smaller coefficient of linear expansion rod will be on. Options on the board here. Outer side, inner side, remains straight, last is insufficient information. In a question, one thing is mentioned, a bimetallic strip is heated. A bimetallic strip is heated. Heated means L is directly proportional to alpha. L is directly proportional to alpha. It is clear from the topic which we discussed already in a class here. L is directly proportional to alpha. Yes, larger alpha, larger will be the length. Larger alpha, larger will be the length. Larger the length will be on convex side. Larger length will be on convex side or outer side. Convex side or outer side. Smaller alpha, smaller will be the length. Smaller the length will be on concave side or inner side. Concave side or inner side. Our question is related to the smaller coefficient of linear expansion rod. So if alpha is smaller, if alpha is smaller, length will also be smaller. Smaller length will be on concave side or inner side or inner side. So what is the answer of our question here? It is inner side. Okay, now we can discuss next question. When a bimetallic strip is cooled, then larger coefficient of linear expansion rod will be on. Yes, first option concave side, second convex side. Yes, C remains straight, and the last one is insufficient information. Insufficient information. Yes, one thing is given in the question. A bimetallic strip is cooled. Cooled means L is inversely proportional to alpha. L is inversely proportional to alpha. Don't be confused by this here. This part already we discussed in our topic here. When a bimetallic strip is cooled, L will be inversely proportional to alpha. L will be inversely proportional to alpha. Now, if alpha is larger, length will be smaller. Length will be smaller. Smaller length will be on concave side or inner side. Smaller length will be on concave side or inner side. If alpha is smaller, length will be larger. Length will be larger. Larger length will be on convex side. Larger length will be on convex side or outer side Now what is our question here? The larger coefficient of linear expansion rod. Yes, if alpha is larger, length will be smaller. Smaller length will be on concave side or inner side. Concave side or inner side. So what is the right answer of our question? It is A, concave side. Okay, one more question. A bimetallic strip is made of two different materials of coefficient of linear expansion of upper strip alpha 1 and of lower strip is alpha 2, where alpha 1 is greater than alpha 2. It is given. If a bimetallic strip is heated by a very small change in temperature delta T, then the mean radius of a bimetallic strip is. Four options are given on the board here. Yes, what is the mean radius of a bimetallic strip? As you know, all students, here we have discussed mean radius of a bimetallic strip R is equal to, it is D times of 2 plus alpha 1 plus alpha 2 into delta T. It is divided by 2 times of alpha 1 minus alpha 2 into delta T. This is the mean radius of a bimetallic strip. But this mean radius is not matching with any of the options which are given here. So how to find out the mean radius for this question? We will take in a class here. Okay, from the question is mentioned here, a bimetallic strip is heated by a very small change in temperature. Yes, it must be clear here. If change in temperature is small, if change in temperature is small, if change in temperature is small, change in length will also be small. Change in length will also be small. What does it mean by this here? If change in length of upper strip and the lower strip is small, then what we can say, L1 will be nearly equal to L2. L1 will be nearly equal to L2 will become equal to L naught, will become equal to L naught. So it should be clear here, if the change in temperature is very small, then change in length will also be very small. At that time L1 will be nearly equal to L2 will be equal to L naught. It should be clear here, L1 will not be equal to L2, L1 will be nearly equal to L2, nearly equal to L2. So L1 will be nearly equal to L2 and this is equal to L naught, this is equal to L naught. So we are taking here L1 is nearly equal to L2 is equal to L naught when a bimetallic strip is heated by a very small change in temperature. Now angle is equal to arc upon radius. What is angle is theta, arc is L1, yes, radius is R1. Now this is nearly equal to L naught by R1, L naught by R1. So theta is nearly equal to L naught by R1. Now again theta is also equal to L2 by R2, L2 by R2. L2 is nearly equal to L naught by R2, L naught by R2. So theta is nearly equal to L naught by R1, theta is nearly equal to L naught by R2. Yes, we can take from here, yes, L naught is equal to R1 into theta, L naught is equal to R1 into theta, and from here L naught is equal to R2 into theta. So the value of L naught is nearly equal to R1 into theta, L naught is nearly equal to R2 into theta, is supposed to be taken as relation number 1 as a relation number 2. Now we can add these two relations here, 1 plus 2, 1 plus 2. What will come here? 2 times of L naught, 2 times of L naught is equal to R1 plus R2 into theta, R1 plus R2 into theta, or we can write L naught is equal to R1 plus R2 divided by 2 into theta, divided by 2 into theta, and this is nothing but as the mean radius, is the mean radius of a bimetallic strip. What is the value of theta? Is equal to L naught into alpha 1 minus alpha 2 into delta t by small d. Now the value of theta we can put here, yes, it is L naught is equal to R, R is the mean radius, R is the mean radius, and the value of theta is L naught alpha 1 minus alpha 2 into delta t by small d. Now from this relation L naught will be cancelled, L naught will be cancelled, and the mean radius will come d by alpha 1 minus alpha 2 into delta t. This is the mean radius of a bimetallic strip. As you know, mean radius of a bimetallic strip does not depends upon the initial length, does not depends upon the initial length. So this is the approximate value of the mean radius is coming on the board here, is the approximate value of the mean radius of a bimetallic strip. So this value is matching with the option number C. It should be clear here, it is not a exact value of the mean radius, is the approximate value of the mean radius.